In our last video, we saw the fundamental theorem of calculus part 1 for the first time that says if I have a continuous function little f, I can build an antiderivative called big F that is defined this way as that net area function, the integral from a to x of f of t dt. I'd like to use the fundamental theorem of calculus part 1 to take some derivatives. So I have 4 examples I'd like to go through. And the big idea here is I'm supposed to find dy dx, I'm supposed to differentiate, but I know from the fundamental theorem that every time I have a function that is defined in this way, its derivative, y prime or dy dx, is simply little f of x. And if I read that as a rule, it simply says the integrand is my derivative, but I need to replace the t with an x. So in this first example, dy dx, well, the derivative is cosine of x. Another way to read this is that if I started with this function, this one is its antiderivative, and that's really what the fundamental theorem of calculus part 1 is telling us, that this equation, if I started with y equals cosine x, would have an antiderivative of the integral from 0 to x cosine of t dt. Moving right along, dy dx in this next example is x over x squared plus 4. All right, so now in this example 3, I need to think just a little bit because I don't have a simple x here. X has been replaced with a function. And this is where I need to think about the chain rule. Well, the chain rule was always about what happened when I replaced the variable x with a function u. And we could always calculate the derivative using the chain rule this way. dy dx was dy du, take the derivative of the function with respect to u, times du dx. So here in number 3, we have a function in the format where instead of having an x in the bound, it's been replaced with a u. So if I think about it, right, if that was y equals, right, some number to the u, and this was just an f of t dt, well then dy dx should be dy du times du dx. Using the fundamental theorem of calculus part 1 on this, well, that part would simply be f of whatever u is times the derivative of u. All right, so thinking about the fundamental theorem of calculus part 1 along with the chain rule, I can find dy dx. The function that is the integrand, evaluated at whatever u is, 3x squared, times the derivative of u, which is 6x. Okay, so we've gotten through number 3, because now we know that all I had to do was apply the chain rule. The function evaluated at u times the derivative of u. And then finally number 4, which looks a lot like number 1, but instead of the bottom bound being 0, the bottom bound is minus pi. Well, if I look at the fundamental theorem of calculus part 1, it says when I differentiate a function in this format, no matter what the bottom bound is, the derivative is just f of x. So if I believe that, my derivative here should also just be cosine of x. So let's see if we can investigate that just a little bit more to make sure there are no questions. Because I've had students in the past who found this uncomfortable at first, that we've constructed 2 seemingly different functions with the same derivative. So if I look at that original function, y equals the indefinite integral from 0 to x of cosine t dt, additivity, I want to look at the second one. Additivity tells me that I could integrate from minus pi to cosine, and then, from minus pi to 0, and then from 0 to x. The additive property of the definite integral tells me that this is true. And then I look at this part. This is a definite integral from minus pi to 0 of some function. This is an area. But more importantly than that, what I've kind of put in this box is a constant. And the derivative of a constant is always 0. So when I take the derivative, this is a constant, the derivative of a constant is 0, and then this part I get to use the fundamental theorem of calculus, part 1, and just tell you the derivative is cosine of x. And that's why these two functions, no matter the bottom bound here, have the same derivative. Because by changing the bottom bound, I've simply changed the function by a constant. And the derivative of a constant is 0.